All right, we know how to do elimination, and what we're going to do today is work on some of the elimination problems where we have to get them set up correctly. So if you didn't yesterday put this in your notes, let's make sure we've got it in there today. The 3 ways to solve systems of equations is by graphing, elimination, and substitution. We're going to be working on elimination again today. Okay, so yesterday we looked at these and we said sometimes we have a really nice problem where the variables are set up so that they automatically, when I add them together, the 2 equations, those y's cancel out, and we're left with just 2x equals -2 here. Then we had some that we looked at where it's close, but we have the same thing, which won't add up to be an elimination of the x's. So what we have to do there is we had to multiply one of the equations by -1. And if we do that, every term changes signs. So that again, when we add them together, the x's eliminate each other. So what do we do if the variables don't just cancel? We can set it up the same exact way, it just requires a little bit of work on our part. So if you go to last night's homework, these 2 problems were at the bottom. We didn't do them. Okay, if you look at the first one, number 9, I have 5x and 10x, and I have y and -7y. Neither of those match, so that if we add those together, the 2 equations, we're not going to eliminate a variable, and we need to eliminate a variable. So what we're going to do is take and multiply one of the equations by something to get them to match. So if I look at this, I could multiply the first equation by 2 and create a 10x. I would multiply it by -2 to create a -10x. I can also set it up so that I make the y's match, which is what I'm going to do. So I'm going to take, and because this y value is negative, I want the one from the top equation to be positive. So what I'm going to do is multiply the whole equation by 7. So I'm going to create a new equation where I do 5x times 7 to get 35x, and 7 times y to get positive 7y, and then 9 times 7 to get 63. So now what I'm going to do is ignore that top one. I am just paying attention to these 2 equations, and I'm going to add them together. When I add them together, I'm going to get 45x equals 45. When I divide by 45, I'm going to get that x equals 1. Okay, just like before, now I'm going to take one of the equations. I'm actually going to go back to this very initial equation and say 5 times the x equals 1. So I'm going to plug in 1 for x, plus y equals 9. So 5 plus y equals 9. And then I'm going to subtract 5 to get y equals 4. So the solution to my system is, again, a point, and that point has an x value of 1 and a y value of 4. All right, let's look at one more. Okay, if I look at this, again, what I'm trying to do is say, should I try and make the x's match, or should I try and make the y's match? You can do either one. So I always look at the small coefficient. So if I were looking at the x's, I say, what would I have to do to make 1x match negative 4x? That's an easy one. I would just have to multiply by 4. Or I look at the green, the y's, and say, what would I have to do to make the negative 3 match with 9? And I would have to multiply by 3. And I can do either one. So it is up to you. I'm going to take, and I'm going to multiply the second one, and I'm going to multiply it by 3. So I'm going to get this new equation that is 3x minus 9y equals negative 18. Just to keep things easy, I'm just going to bring this other one down and have negative 4x plus 9y equals 9. Now I can add these two together. I'm going to get negative x. The 9's eliminate each other, which is what we're trying to set up, equals negative 9. So x is equal to 9. Now I'm going to go back to this equation. I'm going to plug in 9 for x minus 3y equals negative 6. Subtract the 9 to get negative 3y equals negative 15. Divide by negative 3 to get y equals 5. So the point where these two lines are intersecting has an x value of 9 and a y value of 5. Okay, so you try these two. Let me give you some hints here as we start this one. So I'm trying to make either the x's match or the y's match. If I look at number 11, I see that 3 divides into 9. So what I would do on that one, and I'm trying to set up a pair, right, that are opposites, I would multiply this top one by negative 3, so that when I multiply it, I get a positive 9x. And then you can see that 9x and negative 9x are going to eliminate each other. Okay, in this other one, if you look at it, we're going to have to match the x's, which wouldn't be that easy because 2 doesn't go into 7. But I could multiply the top one by negative 3, so that I would have 21x minus 3y equals 57. And so what I've set up in that one is the matching but opposite y values. So finish those. I'm going to pause your video right now, try both of those, and then I will show you the answers. Okay, so there are your answers. On the first one, you should have gotten a solution of -4, -4. And on the second one, a solution of 2, -5. Okay, there's just one more part of this. So far, we've kind of done these elimination problems 3 different ways. One way when it was set up nice and we had an opposite pair. One way where we had to multiply one equation by -1, excuse me, to create that opposite pair. And then today you've seen we had to multiply one of the equations by a number to create that opposite pair. The last one, and the last kind of the elimination, is we have to create that opposite pair by multiplying both equations. Okay, so you look at the X pair and the Y pair and say which is going to be easier to get them to match. Well, if I'm looking at the 3 and the 5, with the X's, I see that I could match those at 15. If I look at the Y's, I can match the 3 and the 4 at 12. So it's just kind of a choice, right? I'm going to go with matching the Y's. So I'm going to have to multiply both of these to create a matched pair at 12. I want to create a positive 12 and a negative 12. So if I multiply this first equation by 4, I'm going to get 12x plus 12y equals 36. So be very careful that you multiply every single term. If I multiply the second one, I'm also trying to get a 12y, but I want it to be negative. So I'm going to multiply by -3. So I'm going to get a -15x and a -12y equal to -30. Now I can take and add these together because my y values are an opposite pair, so that when I add the two equations together, I'm going to get -3x equals 6. When I divide by -3, I'm going to get that x is -2. Okay, so now I'm going to go back to one of my original equations. So let's just say the bottom one. I'm going to plug in x equals -2. So I'm going to say 5 times that -2 plus 4y equals 10. Multiply this out. Try and get y by itself, so I'm going to move the 10 by adding it. So I get 4y equals 20. Divide by 4, and I get y equals 5. So my solution is the point -2, 5. So the other thing that we should be doing on every single problem, and in the videos I've been saving time by not showing it, but we should be testing. So every single time I should be checking and saying, taking the first equation and saying 3 times -2 plus 3 times 5. So I'm just plugging in my answers for x and y into the equations. So I would get -6 plus 15 equals 9, so 9 equals 9, that checks out. Then I would do the second equation. 5 times -2 plus 4 times 5 equals 10. So I have -10 plus 20 equals 10. 10 equals 10. It checks, and I absolutely know I'm correct. Okay, pause your video and try this one. And you've got to decide, am I going to match my x's at 10 and negative 10? Or am I going to match my y's at the smallest thing that both 4 and 6 go into, which is 12? I think it's easier to match the x's on this one because you have one positive, one negative, so it just saves a little bit of complication. So pause your video and try this one. Okay, so if you did this, take a look. I multiplied the top equation by 5, the bottom equation by 2 to create this pair of positive and negative 10. When I solve it, I got a solution of 3, negative 3. That's the point where the lines are intersecting. Okay, so again, if you did not write this down yesterday, you should pause the video and write this down, the steps to solving an elimination problem. So we have to line up the x, y, and the number, and then we need to get one of those, x or y, to have coefficients that are opposites of each other. When we add the equations together, we're going to eliminate one of those variables, get an answer for the other variable, substitute back in, and get the one we don't have. We're going to do just 6 problems tonight. So on homework 3B, 3.3b, you're just going to do 13 to 18.